deep beneath the Arctic. 120 years of corrosion, frozen in time. The HMS Dreadnought, once the pride of the British fleet, now rests trapped in the unforgiving grip of the Arctic ice.
There it is. The corrosion is extensive, over 120. Yes, the bubble structure here confirms the instability we projected for the extraction zone.
There we have it. Full alignment across the hull.
Incredible detail on the secondary guns. The ice data confirms stability for now.
The Dreadnought lies beneath meters of shifting ice. Our thermal analysis highlights the deepest sections in...
Confirmed. Sonar shows viable corridor depth here.
Cutting begins next. At these depths, the pressure is immense. The thermal lance is the only tool capable of cutting through the ice sheet without disturbing the wreck below. Securing the century-old Dreadnought hull beneath the ice ceiling is a monumental task, requiring special...
With the chains now fully taut, the wreck breaks free from the abyssal silt, a monumental feat of engineering.
Tension is increasing on line 3. We have movement. Lowering main cables. Hold steady on the aft.
We have contact on the starboard side. Slow down.
Confirmed. Easy now.
Check the pressure on bogey 7. It looks a little low.
HMS Dreadnought, heavily corroded after a century at sea, begins its slow journey into the
120 years later, the Dreadnought returns. This massive undertaking will see her restored to her former glory.
Maximum pressure achieved. Readings are stable.
Confirmed. The structure held firm against the load.
Okay, bring the laser array up 20 centimeters. Aligning now. Stand by for power up.
Secure that beam on the upper deck.
Copy that. Moving up now.
The first step is removing the residual water. Once drained, these industrial fans ensure the hull is complete.
This fissure near the bilge keel is critical.
Agreed. We need to ultrasound this section immediately to assess the structural integrity.
This entire section here, marked in red, is paper thin. We'll need a full plate replacement.
Agreed. I'll update the schematics.
The ultrasonic readings are showing significant degradation here. We're down to just over 10 millimeters on this plate.
The Dreadnought's century-old hull is heavily compromised. The internal ribs show severe pitting, requiring extensive work.
We need to verify the plating thickness around this section.
The schematic says 42 millimeters, but
See from the overlay, these sections of the hull are severely compromised after 120 years at sea.
The HMS Drought represents a pivotal moment in naval history. Bringing her back requires meticulous work on the one.
The starboard geometry aligns perfectly with the schematics.
Noted. The deviation on the lower plate is within tolerance.
This section here, near the bilge keel, is completely compromised.
We can't salvage it. It has to be cut out and replaced entirely.
The century-old steel is severely compromised. We use a template to precisely map the replacement sections.
All right, steady now. Bring it down another 2 millimeters. Perfect, hold it right there.
Continuous welding is essential here. The molten seam must form a perfect bond to secure.
The structural integrity of the keel is severely compromised.
The readings confirm it. The thickness has dropped.
The stress fractures near the...
The challenge here is stabilizing the century-old steel without compromising its integrity.
The plating here is completely compromised.
But the new section meets all the structural requirements.
It meets the Classification Society standards.
I agree. We can sign off on this section.
Compromised here.
We'll need to double the plating as per the new schematics.
We've completed the final inspection of the lower hull.
It meets all military specifications. The paintwork is exceptional.
Keep her steady on the mark. Watch the port side clearance.
All right, hold it right there, slow and easy.
Hull clearance appears satisfactory.
Agreed. Requesting dive team confirmation on the bulbous bow.
Open the main valves.
Main valves open. Flooding sequence initiated.
Keep the tension on those lines. Steady as she goes.
Firing sequence initiated. Mark the time of the blast.
Recoil observed. Checking stability now.